Okay, these contents will be explained in this video. Definition of a hyperbola is differences of the distances from two fixed points foci are constant. If foci are located horizontally, we can pick a point. This distance minus this distance will be same as this distance minus this distance. So differences of the distance are constant. If you collect all those points, it will form a hyperbola. So here's a foci, here's a vertex. Approximately that will be the situation. If foci are located vertically, we will have similar situation, but this time it will be open, up and down hyperbola. So let me explain generally how you can deal with graphing hyperbola. It will be divided into two different cases. So here, first style is x squared minus a squared minus y squared over b squared equal to 1. Second style will be y squared over b squared minus x squared over a squared equal to 1. Difference between these two styles is structure of equation. Left side we have x squared minus y squared. Right hand side we have y squared minus x squared. So in hyperbola, how do you know it's either open left and right or open up and down style? Depending on what kind of structure of equation that hyperbola has. If x squared came first, minus y squared, open left and right. Y squared first, minus x squared, then it's going to be open up and down. How do we graph hyperbola? You start from the center as a 0, 0, and you go right by a, left by a from the center. So a is the number underneath x, b is the number underneath y. So you go right by a, left by a, you go up by b, down by b, and then you plot rectangle. Once you plot dotted rectangle, then you can form a asymptote. You can draw asymptote by connecting the corners of the rectangle. Draw the asymptote. Since we know this hyperbola is open left or right, we graph hyperbola right there, and that point will be vertex. So this is our hyperbola here, and this will be co-vertex. This axis we call that as a transverse axis, and that axis we call that as a conjugate axis. This line, this hyperbola keep approaching to this asymptote, but it never touches it. This asymptote, we need to know the equation. So y equal to, starting from the center, you go up by b, down by over a. So it should be slowly b over a. So y equal to b over ax. There's another line with the same slope with a different sign. So we have two asymptotes. One will be plus b over ax, the other one will be minus b over ax. Foci will be located somewhere over here horizontally, and distance from the center to foci will be c. The way you calculate c is following this formula. If hyperbola is open up and down, we do exactly the same. From the center, you go to the right by a, down left by a. A is the number underneath x, b is the number underneath y. You go up by b, down by b. Draw the box, dotted line exactly the same way. Draw the asymptote. Only difference here is we do hyperbola open up, open down. That's the vertex, co-vertex. This axis will be transverse axis. That axis will be conjugate axis. Asymptote will be the same way, y equal to plus minus b of x. Calculate c. Once you calculate c, you can locate foci vertically. This distance is c, this distance is c. One thing you have to be careful dealing with the hyperbola is value of a, value of b. If you remember from ellipse, the way we classify ellipse, whether it's laying down ellipse, standing ellipse, is depending on value of a and b. If a is bigger than b, laying down ellipse, b is bigger than a, standing ellipse, that's not gonna work in hyperbola. Be very careful. Value of a, value of b has nothing to do with whether you decide, okay, this hyperbola is open left, right, up and down. So in this drawing, I draw a longer than b. I just did that. B could be longer than a, so then my box will be more like a standing box, but it will be still open left and right. So don't get confused. In hyperbola, value of AB does affect the shape of a box. It does not affect whether it's open left or open up and down. That's determined by structure of the equation. Let's practice some example. So first thing you have to notice is this left, right, or up and down? You can make that call from looking at the equation. Is it x squared minus y squared? Then it should be left style, not right style, because right style should be y squared minus x squared. So just by looking at the equation, you should know, it's open left and right. So you know it's open left and right, just note that value of a is gonna be 4, value of b is gonna be square root of 5, and let's try to graph it. Center is 0, 0, right by a, 1, 2, 3, 4, 1, 2, 3, 4, up by square root of 5, which will be 2 comma something, 2 comma some decimal. So build a rectangle and connect the corner and the center to draw asymptote. Open right and left, so hyperbola you can graph like this. These points are vertex, another vertex here. We need to calculate the c value. So c squared equal to a squared plus b squared, c squared equal to 16 plus 5, c squared is gonna be 21, c squared 21. So it will be somewhere over here, focus, square root 21 comma 0, somewhere over here, minus square root 21 comma 0 will be focus. Don't forget writing asymptote. Y equal to plus minus b over ax. So y equal to plus minus square root of 5 over 4x will be asymptote. Okay, same deal. We need to know, is it open left and right or open up and down style first? by looking at the equation, you should know y square minus x square, it should be open up and down. So denote it's open up and down. Value of a is 5, value of b is square root of 21. So let's approximately graph it. So you will go right by 5, left by 5, up by square root of 21, down by square root of 21, then draw the box. And let's draw the asymptote. Open up and down. So here is a hyperbola. Here is a hyperbola. And that's your vertex right here. So vertex will be 0, square root of 21. Another vertex here will be 0, minus square root of 21. And let's calculate c. C square equal to a square plus b square. So c square equal to 25 plus 21. C square equal to 46. C equal to square root of 46. So foci will be located somewhere over here, somewhere over here, and that distance will be c. This distance will be c. So you got the foci right here. 0, square root of 46. Foci here 0, minus square root of 46. Don't forget asymptote. Y equal to plus minus square b over a. Square root of 21 over 5x will be your asymptote. Okay, before we deal with this, only thing you have to be careful when you deal with graphing parabola, hyperbola, graphing hyperbola with shifting will be something like this. So only thing you have to add from there is considering shifting. So it will be something like this. That was the basic equation of hyperbola without considering shifting, and this will be with shifting. So what's the difference? Same thing, x squared minus y squared is open left and right style. Y squared minus x squared will be up and down style. What's the difference? Center is different. Center is different. So I just assume h, k will be positive for just this demonstration purpose. You go center here is h, k. Everything else will be same. You go a to the right, a to the left from the center, b to the up, b to the down from the center. Build a box. Draw the asymptote, draw the asymptote. Since it's open left and right, here's a hyperbola, here's another hyperbola, and you get to graph it. So that's gonna be a vertex, that should be a vertex. You go to the right by c, left by c to find the foci. How do you calculate c? Exactly the same equation. Asymptote will be slope of b over a, but we have to contain 1 point, so it's like applying Point's law formula in equation of the line. Exactly the same thing with open up and down. Only difference is you have to apply center as h comma k first, then draw the box, open up and down. Everything will be same except you have to apply the shifting. So let's try to practice example with shifting. So when you look at those examples, you should make a call. Are we dealing with open left and right, or are we dealing with a hyperbola with open up and down? So x squared minus y squared, x squared minus y squared. So you should know this is open left and right. So it's open left and right. Value of a is 5, value of b is 6, center is minus 3, 2. So approximate graph. Let's do 1, 2, 3, 1, 2. That's the center. You go right by 2, left right by 5, left by 5, 3, 4, 5. You go up by 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And draw the box. Draw the asymptote by connecting the corners. Open left and right. So here's a hyperbola. Here's a hyperbola. That's gonna be your vertex. So what center was minus 3, 2, and you go right by 5. So vertex is gonna be what? 2, 2 here, another vertex here, minus 8, 2. Asymptote will be y minus 2 equal to plus minus b over a. So 6 over 5 x minus x plus 3. That's the x plus 3 right here. So that's y minus 2, y minus 2, x plus 3, x plus 3. Let's calculate foci. So c squared is gonna be a squared plus b squared. So c squared equal to 25 plus 36. C squared equal to 61. C is gonna be square root of 61. So your foci will be somewhere over here, and that distance, this distance will be c. So you got foci here, minus 3 plus square root of 61, 2. Another foci located here will be minus 3 minus square root of 61, 2.